All right, guys, you should have the 1.5 part 2 pulled up. I added one question on this slide, and then I added another one at the end, just some stuff I want to go over. But yesterday we talked about complex numbers, real parts, imaginary parts. We talked about adding, subtracting, and multiplying, right? We talked about that the square root of -1 is what? What's the square root of -1? No, the square root of -1 is what?
Oh,
I, right? And then if you have I squared, what does that equal? -1, okay? That's very, very important. We're going to talk today, this is the second part of our complex numbers. We're going to talk about simplifying radicals, and we're going to talk about dividing. Now, the division is just two big multiplication problems. You just have to multiply by something called the complex conjugate. We'll talk about that in a second. But if you're just asked to simplify, guys, this is just as you would simplifying radicals that did not have a negative sign underneath. Same exact thing. The only thing that's different is you have to account for that negative that's underneath. So what I think you should do, what I suggest you do at the beginning here, as you're getting used to this, is rewrite this. Let's break it up into -1 times 25. I know you guys all know the square root of 25. And I know you guys all know the square root of 36. But pull this apart so you remember that there is a negative underneath the radical. Because your answer here is not 5 plus 6. It's 5i plus 6i. Right? So it's good to get in the habit of when you separate, when you're breaking down 27 into 9 and 3, you account for that -1 underneath so you don't forget the I. So what you would do here is take out, square root of 25 is 5, square root of -1 is I, so this becomes 5i. Plus, the square root of 36 is 6, the square root of -1 is I, so this becomes 6i. Can you combine those two now?
Yeah.
Yes, what is your answer? 11i. If they ask you, and they will, to write in standard form, a plus bi, that's where the real part is first, the imaginary part is second, you would write 0 plus 11i. Now on WebAssign, if they asked you what the real part, what the imaginary part was, 0 would be the real, and 11 would be the imaginary. You don't put the I with it. All right, so let's look at the next one. Let's break each one up individually so we can see it. I have -27, so I'm going to take out that -1. And then what are two factors of 27 that are a perfect square and a non-perfect square? 9 and 3, perfect. So then I have minus, that 3's on the outside. Let's talk about 48. Have that -1 right here. What's a perfect square and a non-perfect square of 48? 16 and 3. You could do 12, but then you'd have to break it down more. You could do 6 and 8, then you got to break it down more. And then lastly, what do you notice about the square root of 12? Is that positive or negative? Positive, so we don't have to worry about any i's. So break that up. So now when you go through to simplify, the square root of 9 is what? 3. And then the square root of -1 is going to be, so this is 3i root 3. Over here, I can take out what? Square root of 16 is 4, and the square root of -1 is I, so I have 4i. What do I do with 4i and that -3 out in front? Multiply, good. So I have minus 12i root 3. And then what is my blue simplify to? 2 root 3. Now I look at this, guys, and I say, oh, they all have square root of 3. Can I combine all of them?
No.
Why not? Because 2 of them are imaginary. You can combine the imaginary ones. You can combine this as 3 minus 12 gives me -9i root 3 plus 2 root 3. I understand that they both have a square root of 3 attached to it. But there's a real part and an imaginary part. You can't put those together. Now, is this written in standard form? No. The real part needs to go first. So this should be 2 root 3 minus 9i root 3. And there's your answer. That's what I would be looking for on your quiz on Monday. Your quiz on Monday is going to have addition, subtraction, multiplication, division, simplifying, and then solving using the quadratic formula. Basic operations. All right, let's look at this next one. All right, let's go through breakdown. What can I break 50 into? Good. Negative 1, 25 and 2. Okay. Then I have plus 6. What about negative 45? Okay, so negative 1, 9, and 5. Perfect. And then I have minus 3, radical, negative 75. So negative 1, 25, and 3. All right. So now let's go through and simplify. The square root of 25 is 5, and the square root of negative 1 is I. So this becomes 5I. 2 stays inside. My next one, I can take out 3I, correct?
Yes.
And then what do I do with 3I and the 6 on the outside? Multiply them, perfect. So it's plus 18I root 5. And then my last parenthesis, I can take out a 5I. And what do I do with 5I and negative 3?
Multiply.
So I have minus 15I root 3. So now what do I do? You can't do anything else. Marissa says you can't do anything else. True. Can I combine any of these? No. I see, yes, that they're all imaginary, but root 2, root 5, and root 3 are all different radicals. They're not, and nothing is similar. So that would be it. You would just leave it just like that. Since they're all imaginary, it doesn't really matter the order. So you would just leave it just like that. Everybody with? All right, let's look up here. This one. Go ahead and take a picture of it, or you can just write it down. This problem can look kind of daunting. It can look a little overwhelming. So just take each piece separately. I have negative 3 on the outside here, and then I have the square root of 81. Do you know what that is? 9. Yeah, it's 9, so you can just go ahead and write it. Plus 4. Now think about what negative 16 is. Negative 16 is really negative 1 times 16 underneath that radical, right?
4i.
So you're taking out a 4i. Good. Now I come here and I have my minus 2. Well, actually, yeah, we'll do that. I'm going to take out a negative 1 here, a 4, and a 3, right, to break it down. And then I have plus 5, negative 1, 25, and 3. Everybody with me? Let's simplify a little more. What can I take out here? In 4 and negative 1. 2i, yep. And then 2i times 2 times negative 2.
Negative 4i.
So this is going to be negative 4i here. Were you going to ask me something, honey?
Yeah, I equals, negative 1 equals I, right?
I squared equals negative 1. When you take out, when you have a negative 1 underneath the radical, when you bring it out, that's your I. So here, when I simplify this, I have negative 27, correct? And here, when I simplify this, I have plus 16i. And then over here, this becomes 5i. And then what happens with 5 times 5i?
25.
So plus 25i root 3. All right, you've done all of your simplification. Just a little bit here, a little bit there. Is there anything you can combine?
Yeah.
What?
69 4.
Say it one more time.
69.
Oh, I forgot to put it right there. Can you combine anything?
No. Yeah.
Negative 4, 25.
What can we combine, Ozzy?
Negative 4 plus 25.
How come we can combine this piece right here?
Because they both have
Because they both have
the radical.
radical 3, and they both are also what?
Imaginary.
Imaginary. So that negative 27 is going to stay out in front. You can put the 16i here. You can put it at the end. It doesn't matter. As long as imaginaries are behind the reals. But at negative 4 plus 25 gives me what?
21.
So I have plus 21i root 3. If you switch these two spots, that's perfectly fine. If you had negative 27 plus 21i root 3 plus 16i, that's fine. Just make sure the real part is first. Make sure the real part is first. Everybody with me? All right, let's move on to our division. Okay, like I just said, division is just, God bless you,
Thank you.
all it is 2 multiplication problems. But the biggest thing that you need to remember is you have to multiply the denominator of whatever problem you're looking at by the complex conjugate. All right, that seems like, what is she talking about, guys? Complex conjugate is super easy. Here's my standard form of my number, right? God bless you. The complex conjugate of A plus BI would be A minus BI. All you do is make sure the denominator is written in standard form, and then you change the middle sign. And the reason that we do that is this. Am I allowed to have this in math?
No.
No, can't have it. Can we have this in math? No, can't have it. You also cannot have this in math. You cannot have a real number over an imaginary. You can have an imaginary over a real. That's fine. It's okay to be in the numerator, but you cannot have an imaginary. You can't have an I in your denominator. So when you multiply by the complex conjugate, your I's will cancel out. So we're going to do these practice problems, and then we'll be finito. We're going to do B first. I'm not sure why they did B before A. But 7 plus 3I. Do you guys agree with me that this denominator is really 0 plus 4I?
Yeah.
You don't have to write it. I'm just showing you. So what would the opposite? I want the complex conjugate. What would the opposite be of 0 plus 4I?
0
Minus 4I, right? Be negative. What you do to the bottom, guys, you do where? To the top. Every time I do a division problem, I tell everybody, simplify the denominator first because you want your I's to cancel out. You can check yourself. You can check and make sure you don't do a lot of unnecessary work by multiplying the denominator first, because if your I's don't cancel out, then you missed a sign. If I multiply 4I times negative 4I, what does that give me? Negative 16I squared. As soon as I see that I squared, what do? I cross it off and I change this sign because that's really negative 16 times negative 1. Did my I disappear from the denominator?
Yeah.
Which is exactly what we wanted. Now you can just go through and say, okay, well, 7 times negative 4I is negative 28I. And then 3I times 4I is negative 12I squared. What do I do when I see I squared? You cross it off, change that sign. Now, is my numerator written in standard form?
No.
No. So you would rewrite it as 12 minus 28I. And then the last thing you always have to do is simplify. So like I told you guys to do on your quadratics test, anytime you simplify and you have 2 terms in the numerator and 1 denominator, I would rewrite it separately. 2 reasons I think you should do this. 1, it's easy to see. Sometimes 1 term simplifies, the other one doesn't. And 2, I think this is how WebAssign wants the answers entered. But what can you divide 12 and 16 by? 4. So this becomes 3 over 4, right? And then what about 28 and 16? 4. So this becomes minus 7 over 4. 7I. Now, for me, if you want to rewrite it as 1 denominator, if both denominators are the same, I'm fine with that. If you want to keep it separated, that's fine as well. But I think WebAssign, I'm pretty sure you have to separate like that. But sometimes the denominators aren't the same, so that's why it can get a little confusing. All right, let's look at letter A. Now I'm going to work out A incorrectly first to show you what I think you should do when you're solving these on a test or a quiz to check your mistakes. But where is the problem? Where's the issue, I should say? Where? In the bottom. So some of you are going to go through and you're going to be like, okay, I got to multiply by the bottom. Don't do this. Right? You're like you messed up your signs on your midpoint formula or the quadratic equation or lots of formulas. We got our signs mixed up. So just say you do this. Well, what's the first thing I tell you all to do? I tell you to simplify the denominator first. So 1 times 1 is 1. 1 times negative 2i is minus 2i. Negative 2i and 1 is minus 2i. Negative 2i is plus 4i squared. Agreed? Yeah. Now I cross off I squared and I change that sign. and I simplify real with real. 1 minus 4 is negative 3, and then I have minus 4i. Did I eliminate the denominator? Did I eliminate the I in the denominator?
No.
No. So if you guys get there, you should be like, oh, wait, I did something wrong. What did I do wrong?
You didn't make it a positive.
I didn't make it a positive. You have to multiply by the conjugate, the opposite. Because when you multiply by the opposite, the middle terms will cancel. So I think it's a good idea to always check the denominator first. Before you do the whole numerator, check to see if you multiply by the right thing. So when we FOIL the denominator, 1 times 1 is 1. 1 times 2i is plus 2i. Negative 2i and 1 is minus 2i. Negative 2i and 2i is minus 4i squared. Everybody with me?
Yeah.
What do I do with I squared? Cross it off, change that sign. So real with real. What is 1 plus 4? 5. What happens with negative 2i and positive 2i? They cancel out. Is my I gone?
Yeah.
Yes. So therefore you know, oh, okay, I multiplied by the right thing. Now, simplify the numerator. What's 3 times 1? 3. 3 times 2i. Plus 6i. Good. 5i times 1 plus 5i. What's 5i and 2i? Plus 10i squared. You guys see that I squared? We cross it off. We change that sign. So real with real. What's 3 minus 10? Negative 7. And 6i and 5i is? Plus 11i. Now this one's kind of simple to see that it does not simplify. But just get in the habit of going like this. And go, okay, yeah, no, nothing simplifies. I would take either answer. It's fine the way you wrote it. You can keep it separated or you can bring it back together. It doesn't matter. All right, let's do examples. I want to do all these with you guys.
We change one side.
In the denominator when you multiply. We're going to do a bunch of these. The last two, I changed the last one on the left and then I added one on the right. When you have just a monomial, it's not that big of a deal. I see positive 4i. Well, I want the i's to cancel out, so what's the opposite of positive 4i? So I'm going to multiply the bottom by 4i. What you do to the bottom, you do to the top. So let's simplify the bottom first. What is 4i times negative 4i? Negative 16i squared. When you see that I squared, you cross it off and you change that sign. Did the I disappear from the denominator?
Yeah.
Yes. So now we simplify the numerator. What's negative 5 times negative 4i? 20i. All right, and now can we simplify this? Yes, to what? One sec, bud. I can divide top and bottom by 4, right? Becomes 5i over 4. Question?
Wait, is the 4i negative since it's, like, on the left it's negative 5 over 4i? Would it be negative 4i times negative 4i?
Well, okay, it just depends on how you look at it. If you put the negative here, then you would multiply this. And then you would not include it with the 5.
So if it's like all the way to the left, then you just 4i times negative.
You can attach that negative sign to either the numerator or the denominator and then just work accordingly. If you put it in the numerator, then you would keep it with the 5. If you put it in the denominator, then you'd multiply by positive. Yeah, good question. Yes.
What would that be like the thing you multiply by? Why
Yes.
would it not be negative 5?
Hold on, can we let me
Yes.
get there? That's a good question. All right, and I'll show you why it won't be. That's a very good question. We're going to multiply by the complex conjugate, guys. We're going to change the sign in the middle when we're in standard form. All right, so the question was posed, how come you don't change both the signs? Well, what do we want to happen? The i's to cancel out. So if I multiplied, what'd you say, negative 5 and then negative 8i?
Yeah, negative 5.
Okay, don't copy this down. Just watch what happens. If we multiply, we get 5 times negative 5 is negative 25, right? 5 times, then I get negative 40i, correct?
Oh, right.
Positive 40i, and then I get negative 64i squared, right?
Right.
So this cancels, and then this becomes this. Do my i's cancel? Yes. But then I have negative 25 and a positive 64. And that's not what we're going to come out with. It's going to change the whole value of your entire expression if you do that.
Oh, so then what happens? Are there going to be 3 terms in the bottom? Or
No.
Oh.
You're always going to just multiply by the complex conjugate, which is, that's why I said don't write this down. You only want to change the sign in the middle. The sign in the middle. So when I rewrite this, what is the sign in the middle? My complex conjugate would be 5 minus 8i. Make sure it's in standard form and just the sign in the middle. So when I multiply the bottom and the top by the same thing, again, simplify the denominator first. Make sure you have your signs right. 5 times 5 is 25. 5 times negative 8i is negative 40i. 8i and 5 is positive 40i. And then 8i and negative 8i is negative 64i squared. When I see I squared, I cross it off, change that sign. Now what happens here? Real with real. What's 25 and 64? 89. And then what happens to my 40 i's? They cancel out. Is that what we need to happen? Yes. So now you can go ahead and multiply the numerator. What's 9 times 5? 45. And what's 9 times negative 8? Minus 72i. Are we in standard form? Yes. Do I need to do anything else? Nope. So I have 45 minus 72i. And this is where I would say, okay, let's pull it apart just to make sure nothing simplifies. Does it? Yes or no? No. So either answer would be fine. No, that's a good question. Just say, Jad just asked a good question. What would happen if we had like 8 plus 9i over 4? This is why I tell you guys it's really important to simplify and to separate. You guys cannot go like this and say that that's simplified. That's not the way it goes. You'd have to pull it apart and you would have 8 over 4 plus 9i over 4. 8 over 4 would become what? 2, and then it would be plus 9i over 4. That would be the correct answer. So it's just a good habit to get into pulling it apart because there might be sometimes when the numerators and the denominators simplify differently, where your denominators aren't the same. So good question. All right, let's come down here to this one. Just because it leads with a negative, that doesn't mean anything. When you multiply by the complex conjugate, which sign do you change when written in standard form? The middle. So my denominator is going to be multiplied by negative 2 minus I. Whatever you do to the bottom, you do to the top. So let's simplify the denominator first. Just make sure the i's cancel out. Negative 2 and negative 2 is 4. Negative 2i and negative 1, or negative I is plus 2i. Why am I putting this on top? Sorry, I meant to put it in the denominator. There it is. So I times negative 2 is minus 2i. And I times negative I is negative I squared. Yeah? So think about this, guys. Negative I squared is the same as what number? Negative 1, right? So if you have minus a negative, what does this become? Plus 1. Sometimes it's hard when there's no number in front. So when you combine your reals, 4 plus 1 is 5. And what happens with two i's? They cancel out, which is what we need. So now we multiply the numerator. Negative 7 and negative 2 is 14. Negative 7 and negative I plus 7i. Negative 6i and negative 2 plus 12i. And negative 6i and negative I is plus 6i squared. You got that I squared, so cross it off. You're multiplying by negative 1, so change that sign. So real with real, what's 14 minus 6? 8. And then 7 and 12 is? So plus 19. Whoops, forgot the one. I over 5. and just pull it apart. I know you guys can see that this doesn't simplify, but just pull it apart just to make sure. And if it doesn't, either way is perfectly fine.
Miss Meadows,
Mm-hmm.
will there be times where the numerator, not the numerator, the denominator isn't in standard form, but it's in the fraction form?
Mm-hmm.
So
And you'd have to fix it. Like if we come to one of the ones on the bottom, yeah. Denominator's in standard form, yeah? Okay, so what's the complex conjugate of 5 minus 10i? Perfect. 5 plus 10i. What you do to the bottom, you do to the top. So 5 times 5 is 25. 5 times 10i is plus 50i. Negative 10i and 5 is minus 50i. And negative 10 and positive 10 is minus 100i squared. I see that I squared, I cross it off, I change that sign in front. So now my reals are 25 plus 100, which is 125. What happens with a positive 50i and a negative 50i? They cancel, which is exactly what we need. So now the numerator. 4 times 5 is 20. 4 times 10i is plus 40i. So you have 20 plus 40i. That definitely simplifies. So 20 over 125 plus 40i over 125. What goes into both 20 and 125? 5. Good. 20 divided by 5 is 4. 125 divided by 5 is 25. What goes into both 40i and 125? 5. So it becomes 8i over 25. You can leave it like that, or you can put it back together since both the denominators are the same. Either way. Either way. All right, let's go over here to this one. I changed it. Yes, sir.
Okay, so negative I squared equals negative 1 or 1.
Negative I squared, right? So we would cross this off. This is negative 1, right? So negative 1 times 1, negative 1 times negative would be positive 1. I squared equals negative 1. So negative I squared would be positive 1, yeah. All right, I changed this one, so just fix it on yours. Standard form of a denominator, perfect. So what is the complex conjugate of 6 minus 9i? 6 plus 9i. 6 plus 9i. Good. So let's work on the denominator first, just to make sure we're good. 6 times 6 is 36. 6 times 9i, 54i. Negative 9i and 6 is minus 54i. And negative 9i and positive 9i is minus 81i squared. What do you do when you see I squared? Cross it off and change that sign. Good. So I have 36 plus 81 gives me 117. What happens with 54 i's? They cancel out, which is exactly what we need to happen. So now, numerator. 10 times 6 is 60. 10 times 9i is plus 90i. Negative I and 6 is minus 6i. And negative I and 9i is minus 9i squared. I squared, cross that off, change that sign. So real with real, what's 60 plus 9?
69.
And then what's 90i minus 6i?
84.
Plus 84i. So let's see, does anything simplify? These numbers are kind of big and kind of yucky, so let's look at them. All right, I know that 2 is not going to go into 69 or 117. What about 3? How do you know if 3 goes into a number? Add up the digits. What's 9 plus 6? 15? 3 goes into 15. What's 7 plus 1 plus 1? 9. 3 goes into 9. So you can divide this by 3. 3 goes into 6 2 times. 3 goes into 9 3 times. On the bottom, if you can't do this in your head, write it right here. 3 goes into 11 3 times, right? with 2 left over. So this would be 39.
Yeah.
Okay, that's fine. Can you simplify that more? No. Okay, so plus, again, what's going to go into 84 and 117? 3. So 3 goes into 8 2 times, right? Look, if you need to write it down, write it like this. 3 goes in here 2. 2 left over. So this would be 8, 28. And we just did 117 divided by 3, 39. So sometimes, guys, you're going to get numbers that aren't beautiful, but they can be simplified. So you just break it down and go back to your basic math computation. You guys can figure it out. All right, Camilo asked a good question. That's why I have this one on here. Go ahead and multiply by the conjugate. Well, wait a second. Is your denominator in standard form? No. Let's go ahead and rewrite this so we don't mess up any signs or anything like that. We get our problem correct. Plus I. I'm going to rewrite my denominator as -2 plus 12i. It's -2 plus 12i because the sign in front of that 2 stays with it. So now when we look at this, what is the complex conjugate of -2 plus 12i? -2 minus 12i. To the bottom and to the top. Rewrite in standard form and then change the sign in the middle. So let's work on the denominator, make sure we did that correctly. What's -2 times -2? 4. -2 times -12i plus 24i. 12i and -2 minus 24i. 12i and -12i minus 144i what? Squared. I see I squared, so I cross it off and I change this sign. So real with real, what's 144 plus 4? 148, good. What happens with my 24i and my -24i? They cancel out. So now I look at my numerator. -8, -2 is 16. -8, -12. 12 times 8. 12 times 8. 96. 12 times 8. Yep, 96. Okay. Positive or negative? -8 times a -12i is going to give me positive 96i. Then I have I times -2, so minus 2i. And then I times -12i is -12i squared. I see I squared, so I cross it off, and I'm going to put a plus sign right there. So real with real, what's 16 plus 12? 28. 96i minus 2i. Plus 94i. All right, big numbers, but what do you notice about all three of these numbers? They're all even. That means 2 will at least go into it. So I have 28 over 148 plus 94i over 148. Instead of spending a bunch of time trying to figure out the biggest number that goes in, just start with 2. If I divide the top and bottom here by 2, I get 28 divided by 2 is 14, right? What's 148 divided by 2? 74. Good. Oh, can I get that a little smaller? Yeah. If I divide top and bottom by 2 again, 14 divided by 2 is 7, and 74 divided by 2 is? Do it over here. 74 divided by 2 goes in 3. Okay, 37. Good. So now, right-hand side, same thing. Start with 2. What's 94 divided by 2? 94 divided by 2. 47 over 74. 47i over 74. Is that going to simplify anymore? Yes or no? So this is going to be 7 over 37 plus 47i over 74. Do you see how the denominators are not the same here? You cannot rewrite them as the same. So that's why I think it's really important, guys, to pull your fraction apart, pull your terms apart, and simplify, because sometimes they'll simplify the same, sometimes the denominators will be different. Ozzy?
If you didn't pull them apart, you wouldn't be able to simplify it.
If you didn't pull them apart, you would miss that simplification. Like it's easier when they all simplify by the same thing and the denominator stays the same. It's like sometimes it's easier to see. But you can see here that they're all even, so you know it's going to simplify some. But if you don't pull them apart, you won't get the full simplification. Yeah, good question.